Okay, cool. It looks like it's 1 after the hour. Welcome everyone to the working from home edition of the OpenZFS leadership meeting. I hope you're all staying safe and socially distanced, if not isolated. Let's get started. We have a bunch of, I think, interesting topics for today. So the first one on the agenda is my topic. The deprecating of ZFS, deduplicated ZFS send streams, and all the pieces of work associated with that. So folks might have seen that we added the message to say that those are deprecated in master, and that'll be backported to 0.8. So the next release of ZOL 0.8 will have those messages in there. And I have a PR open to add a utility ZStream and a subcommand of that ZStream redupe to take a deduplicated send stream and turn it into a normal one, so that you'll still be able to receive any old dedupe send streams that you have, or generate those dedupe send streams on systems with older software that still has it, and receive it on newer software indefinitely. So that PR is open. If folks have feedback on the design, the user interface, now would be a good time to get that feedback in. I also incorporated the functionality of ZStream dump into the new command. So now it's ZStream space dump, and the ZStream dump, one word, is maintained as an alias to keep doing what it was doing before. And then the next step in that project is going to be actually removing the functionality to generate and receive those send streams, and that will land in master after the redupe utility. Questions or comments about that?
So that utility is going to ship with all the other utilities?
Yeah. So it'll live kind of next to ZStream dump and the ZFS command and all the other stuff.
Cool.
And it's pretty, it doesn't have a lot of dependencies. Like, most of the code is just like in the one, it does link with libzfs, but kind of makes minimal use of it. So it shouldn't be, we shouldn't have to do a lot of work to maintain that. Kind of similarly with ZStream dump, like it just kind of sits there and works. So hopefully we can kind of move forward with ignoring that in the future. Cool. All right. So the next item that we had was Mike. Did you have Mike wanted to talk about a new API for the administrative interface of ZFS.
Yep, I put together a little presentation. Let me go ahead and share that. Can you guys see that?
Yep, go ahead.
All right, sweet. So, hey guys, I'm Mike Carlin. I'm going to be presenting basically a little proposal for something called libZFS API. All right, so first question, right? What exactly is this? We already have libZFS and libZFS core. What's this additional library and what's the point? So essentially it would be like an alternate API for applications to integrate with ZFS. It would essentially have a set of functions equivalent to what the CLI commands provide. That'd be like zpool create, zpool destroy, list, all those different functionalities would have an equivalent. But the main deal would, it doesn't need to be exactly equivalent. The main idea would be make it idiomatic and still easy to use. So one-to-one is not extremely important, but something that is very usable. So the motivation behind this essentially is just to really simplify integration for applications that want to administer and monitor ZFS. A lot of the integrations I've seen with other tools like Moby, Lumina, they essentially call out to all the CLI utilities, zpool, ZFS, and then parse that output back to some data structure that matches something they have. I'd like to see if we could have an API that they would use this instead. There's some stuff in the CLI utilities, some business logic there, I'll get into a bit later, that if you were to try to mirror exactly what the CLI is doing, you'd have to add some additional fluff to what libzfs and libzfs core provides. So this layer could accommodate that, so no one has to do that twice. Also, when you're calling a library rather than shelling out to ZFS or zpool, you have a lot less overhead. And for me personally, I like to keep what I'm using usually native to the exact language I'm in and not shell out if possible. So this would be really great. One thing that's really cool would be very consistent expectations between what happens when you do a CLI command and exactly what happens with the API. This is very akin to kind of what AWS has done with their APIs, that there's always a CLI and API equivalent, and you have a very common context as to what that means. So what would this look like, right?
Can I interrupt to ask a question
yeah, sure.
about the motivation, just to clarify? So it sounds like part of this is that is part of this that people are familiar with how to administer ZFS using the CLI, and then they're like, now I need to write a program to do what I used to do with a shell script, or whatever. Like my product needs to integrate with what I know how to do manually on the CLI. I want to have like a easy, as simple as possible kind of translation of like, at the CLI I type whatever, ZFS, whatever, and I want my program to do it, but I don't want to have to do with like parsing a bunch of command output or, fork executing.
Exactly.
So, okay, gotcha. So
that's kind of the idea.
So these kind of consumers would be fine with like the same things being errors as are errors on the CLI. Maybe it'd be nice if they could like parse them out a little better or whatever.
Yeah, just a really
Okay.
consistent. So you do one thing in either area and you know exactly what's happening. I mean,
Gotcha.
they're pretty close anyways, right? It's not like libzfs and libzfs core are drastically different than what's happening in the CLI, but
yeah, I think the other thing that could help motivate this is like what like libzfs is like kind of sorta trying to be what you're talking about here, but not quite. So like, why doesn't, like, what makes libzfs hard to use in this use case?
Some of it comes down to it does a lot of standard error output and standard out output, so you don't really get the context back up if you call the API. There's some of that in certain places. A lot of it wasn't straightforward at first, but
a library should never print to the standard file descriptors, or
totally agreed.
Or it should never exit. It shouldn't do things like that. It shouldn't fork processes. There are like a lot of rules that make a good, like a library that's at least possible to consume safely, and I don't think it really follows those patterns today.
Yeah, I think libzfs follows some, but not all of those patterns.
Yeah, I would almost be fine if this lived in libzfs. I just don't want it to be confused. So if it's standalone, it's very clear that you just use this, and you don't need to go further down unless you're doing something very specific and you need to skip.
Yeah, so the tricky thing about implementing this is like, on the one hand, you're saying it can do just the same thing as the API as the CLI, in which case, like, great, like the CLI is already using libzfs, so we just like, move a bunch of stuff from ZFS main.c into the library, and then job done. But then you have all the same behavior of libzfs. So like, if you don't like the fact that if you think there's missing functionality in libzfs, then I think this kind of makes sense. But if you're saying libzfs does the wrong things, then you can't just like take the CLI and use that code, because that is using libzfs, right? So if libzfs is like printing to standard error, and you're like, I want my new utility, my new library to not print to standard error, then you got to go find all the, you knew library is going to be using libzfs, presumably, since that's what the CLI is doing. So now you have to go find everything in libzfs that does stuff that you don't want, like
Totally.
exiting or printing or whatever, which, like, I don't think that is as ubiquitous as it might be made out to be, but there's definitely work to do there.
And totally agreed. I was intending that to be part of this, to essentially modify those places so there's always a consistent return up of an error code / description rather than anything being outputted. I don't think that's super far across the board, but there are places where it happens. So that was kind of stuff like, okay, I would change libzfs, but at the same time, I don't know who consumes that. So there's those questions too. I don't want to break anybody who's expecting that.
Yeah,
It's
that's part of what
pretty-
makes it a bunch of work.
I mean, it's pretty explicitly unstable though, right? Like,
I was going to say one of the things we're always told is libzfs core is API stable, but libzfs is not.
right. So this new thing could be stable.
I would be, as I said in the chat thing, I would be totally in favor of that, because we wrote we, and I presume many other people have written Python interfaces for ZFS, and it'd be nice to have it simplified a bit.
Yeah, and that's exactly what the intention is, just really simple, straightforward. Just like the CLI is. I love the CLI. It's really well done. So anything akin to that would be awesome for me.
I think if I can say a little bit about that, because I spent a quite significant amount of time wrapping the CLI in zREPL. And as a part of that, I also read through a lot of code in the CLI, libzfs, and so on. And I think ZFS has, like, what is in the OpenZFS repo actually already exposes a lot of API service. For example, the Python bindings, although they are contrib technically, they already show how much work it is and how much duplicate code there is, for example, for figuring out what exactly a system call error means in the context of a particular system call. All that code is already duplicated in the PyZFS bindings, if you can call them bindings, because there's actually a lot of logic in there. So I think one key aspect that needs to be figured out before we write yet another library that exposes ZFS functionality in a different way is how we transport errors from user space, from kernel to user space. And I think we already talked about this a few months ago, but there are a lot of points in user space where the caller of the system call needs to figure out what the system call return value means based on the context that, like, for example, exist or inval is heavily overloaded.
No, that's a good point for sure. Those are things that'll need to be addressed. I don't necessarily have answers to any of that. It was just kind of it would be nice if this was here, but thanks for that. I guess I'll continue along unless someone has anything else.
I think the main point of what he was saying there was, look what other people have done, and try to see how you can improve it and help them improve their implementations. As I said, if PyLibZFS could be done on something that is more consistent and stable, that means everyone wins. Does that make sense?
Yep, totally.
Also, yet another thing that I talked to a few people at the last 2 developer summits about that. I have a experimental patch that is halfway done, but it has been sitting around for such a long time that I don't think it would apply now. But I think it would be pretty awesome to have a stable kernel interface that is based on just NV lists. So we put in an NV list, we get out an NV list, and that's all that is to it.
That's, I mean, I imagine you've seen all the new ioctls are of that format.
Yeah, exactly. And I would opt for, like, if we go for having a cleaner like API to ZFS, I think that is the right layer to start. Cleaning up the old ioctls and being able to issue the ioctls from any programming language with fairly little effort.
Yeah, but that's like a very different goal than what's being discussed here, because those ioctls are way lower level than what the CLI does. Where like imagine you're like ZFS create -o blah 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 whole, you know, file system. There's a lot of like parsing of that stuff before you can get down to the env list. Or like, how about ZFS destroy? ZFS destroy -R something at something with a % in it. So you're doing like a range, you want to destroy a range of snapshots in each thing that's below this point and all of their clones and whatnot. Like that's, and maybe you do like -n, you just want to get like the list of what it would do. Like there's a lot of stuff there that is not, it's like a lot of different ioctls to put that all together. I mean, that's why libzfs is, you're saying like, just don't use libzfs. Which is great when you can do that, when you put in the effort to do that. But you know, libzfs is like, I haven't looked at it recently, but it's probably like 50,000 lines of code. So that's a lot of functionality that you're getting.
And if
that
the
kind of
goal,
makes up the
if
CLI.
the goal is to have like common business logic, as it were, between the CLI and this library as much as possible, I think it probably needs to live in the library. Yeah.
Yeah, okay, I see that.
All right, I'm gonna move forward unless someone's got something else. All right, so what exactly does this look like? I just did some preliminary looking through what's available in zpool main, ZFS main. There's a lot of forward declarations, do ZFS asterisks, do zpool asterisks that kind of make up the different CLI commands. I kind of just tried to one-to-one those as much as possible. Matt had brought up some use cases where maybe it doesn't make sense to be one-to-one. So if it doesn't make sense, we shouldn't do it that way. But by and large, this is kind of the idea. Any business logic that's present in zpool or ZFS kind of gets shoved down to the libzfs API layer. This would be anything that's not really a CLI related concern. Zpool and ZFS would attempt to use libzfs API where possible. Not only would this provide usage of the library and how to use it, it also gives you test coverage over any changes we've made, because there's a lot of backing tests to validate zpool and ZFS. The libzfs libzfs API wouldn't output the standard error, standard out. You just return error codes and descriptions, leaving the client in charge of how to output that. If it was a REST server, the REST server would return a JSON error format text, right? If it's CLI, it decides to output the standard error, standard out. We would leave that focus of control on the client, but they would have all the data necessary to make those decisions. That's kind of the idea. It's definitely a first pass. There's stuff to be iterated on. So a first example, if you look at zpool destroy, this is, oh, sorry, let's pop back. If you look at zpool destroy, it's fairly straightforward. It's kind of a simple contrived example, but I think it will prove to be useful for this. The main piece here really is the disabled data sets. This is kind of validating things are good beforehand, making sure all of the data sets are unmounted and an additional logic there before we attempt to do a destroy. If you were to duplicate this just linking against libzfs, you'd have to make this call yourself beforehand anyways. This is just a simple piece of business logic that I think could be pushed down. Other pieces, the open and close, I don't think it really needs to live at this layer. There's nothing specific as to why this needs to be here, at least within what I've looked at so far. There might be other cases where this proves me wrong, but for this case, I think it can push down. So essentially what this ends up looking like if we were to rewrite this with the changes is now, so this ellipses here is basically CLI parsing. Oh gosh, I'm clicking too much here. So this is the CLI parsing. We get the pool name. We call our libzfs API pool destroy, which just takes the name of the pool, whether we're forcing it or not, and the history string. I don't remember what the history string's for, but it's part of the call down. It returns an error code, and we decide what to do from there. So if we didn't succeed in destroying the pool, we follow some of the same logic from beforehand. If there was a slash in there, we're assuming, hey, you really meant to destroy a volume, you should probably call ZFS. If we failed otherwise, we're going to try and relate that back up. This is not equivalent output to what's there. That's a little more complicated to get equivalent output, which would be another hard part of this. But essentially, we'll try and use that error code to output why this didn't work. And this kind of leaves all of the output in the CLI layer and nothing below is the intent.
So one question I have is like in the error, like I think as we mentioned, given the error code, the number, like getting the text that describes that accurately is complicated. How much would you want to do that in the library versus in the consumer? Because I mean, like I think you could still do all of that in the library and have it, like you said, it could just pass up a string that's like, here's the string that describes the error, and by the way, here's the error number. But like most people wouldn't use the error number. They would just be like, great, here's the string. I will, you know, printf it or like put it into my JSON results or display it on your screen in some font or whatever.
Yep. Yeah. So it would be in the library. This is an old example from the very first thing I put out before we discussed the error stuff. So I would rather it be a structure with a code plus the description and not rely on the consumer to ask for a string somewhere. It should just trickle up.
Yeah, sure. But the point being that like the string is generated in the library and the consumer is basically just like taking this opaque string that describes the error and returning that or printing it.
You probably wanted to sort of two things. I think you want that string. Like, so I think the string that the CLI would emit today should come out as a property in an error object, but it'd be good to be able to support other properties. You know, like if the destruction for like if the destruction fails because it can't unmount a particular file system or a particular set of file systems, you could have a list of those file systems or the data sets or whatever, in addition to the message and in addition to a code. So like getting an NV list back or something.
Oh yeah, that would be useful for sure.
And also I think it'd be probably good to have like I see the call up there, the destroy call. You've just got like the arguments of the call. It'd probably be good to have like a library handle as well for all these calls. So you like open the library or init the library or whatever, and then if you want easy mode, you can ask the handle with a particular symbol for like the easy string. And if you want more complicated error messages, or if we want to evolve the way that the errors are reported over time, we can add symbols that refer back to the handle to unpick the error state in more and more complicated ways, rather than what we've got there with the conversion of the raw number, or even including the like an error pointer in the arguments to the function. They're all sort of limited in that like once it's there, it's difficult to evolve that interface. But whereas here you could have like LZA pool destroy handle pool history string force, and then you know if it doesn't go well, you could have like get error NVL or get error list of devices or something. Like we could add additional symbols that refer back to the handle and look at the failure state of the last operation without having to necessarily have completely designed that into the original call, I think.
No, that's a good idea. I had originally kind of followed how libzfs core had embedded it in it and hold on to a handle under the hood, and you wouldn't pass handles down to stuff. But this makes a lot of sense for this case to do that. We can hide it behind that.
Yeah,
Josh,
there are other. Oh, sorry.
Sorry, I would say, Josh, that particular interface wouldn't be thread safe, right? Is that? Do you think that would be okay, or do you think that we should do something where it's like returning an error thing that you can then inspect?
So I think it would be. So I think if you've got 5 threads and you want them to be able to do different things at once, I think you should open a handle per thread, basically. So like,
okay, all right.
The thread safety would be around, like it would be up to you to
At the
manage
handle
the
level.
thread safety at the handle, and we could make the handle lock and unlock correctly inside so that it's like memory thread safe. But
Yeah.
But
All
then
right,
you
cool.
just have to make sure. Yeah. So like I think you
That's
could do
how
that.
libzfs works as well.
Right.
Like,
Yeah,
you need
I think
you need one libzfs handle per thread, but like those threads
Right.
can do whatever they want.
Right, and they can be pretty cheap handles underneath. Like it's probably just going to be a struct with some storage, you know.
Yeah, and there are some interfaces like ZFS send that give output as it goes along. So having a callback that's able to as this output would normally be generated, the callback gets called so you can do progress indication.
Because it manages threads under the hood, right? The send. Maybe.
I don't think that send has a thread. I think it just does a IOCL per data set.
Well, the send, if you report progress during the send, then the library does create a new thread to like the main thread is doing the
right,
send
yeah.
IOCL. It creates another thread that's querying it every however long you
right.
you ask for it.
I wasn't thinking of proper progress reporting. I was thinking of like the send-v, where it just is outputting the name of the data set as it goes along.
Right. So what exactly does LZA pool destroy even look like under the hood? Essentially, we've pulled down the zpool open, the zpool close. The disabled data sets is in here now. LibZFS API maintains its own handle to LibZFS or in LibZFS core where applicable, and essentially would return the error codes. But as we've discussed, the error stuff is going to evolve and be different. But this is essentially the idea, and then you would have total understanding of what's possible to return, what those things mean, if you so were going to use the error code. I don't even know that this perfectly reflects what it is, but this was my best attempt in a quick time to do this.
I think throwing out the overlap with ONO is a really good idea. I think like having a separate set of enumerated return codes is a much better idea than.
Okay. There was a lot, so I was like, I feel kind of bad because it's going to dupe a bit, but
it's really fine.
That,
it's really,
that was a design mistake from the beginning.
It's fine to have 1,000 definitions in that enum if you have to reflect the state of whatever. I mean, just there's no reason to try and preserve the like busy means something that it doesn't mean thing.
All right, for sure. That's kind of all I had. It sounds like we've kind of had the discussion, but if there's anything else you guys want to bring up.
I think, my kind of takeaway from this is that like this solves a real problem, and I think that it is doable. I think that the bulk of the work here is in the error handling, because that's probably where libzfs is weakest. Moving the code around from ZFS main.c into a library is like not that hard. And it's separating out the parsing into a clean interface of like the parsed arguments to the that will be passed to the library, but the error handling is where you have your work cut out for you.
Yeah, for sure.
But I think this would be, I mean, I agree it's useful and it'd be really great to see this.
And as far as I think upfront, careful upfront ABI design will be important too, in order to be able to make it from the first version to make it a stable library that we can commit to. I think it'd be important to make sure that we don't make, there are a number of like subtle C and ELF relocation design issues with stable ABIs rather than APIs, which I think we'll just want to make sure we don't accidentally tickle those, I think.
Yeah, I think we've made all of those mistakes in one place or another in libzfs.
I mean, yeah, but it was, I mean, as an internal component, I mean, it is definitely not designed to be a stable API.
Yeah,
though.
I mean, like as an internal component, i.e. like here's a bucket of code which like some of which is needed by a bunch of different commands. Like it's fine, but in reality, we probably would, like, if I had it to do over again and had the time, I would have, like, if we didn't have the time to make a real API, like we could have just put all of that, like not even make a libzfs and just have like one giant binary that you can invoke by calling it ZFS or zpool or whatever, you know, because that's kind of more honest about how that code is really structured. Like the line between like you know, the zpool command and libzfs is super blurry.
I have a remark on the software engineering angle on that, in particular about the error handling case. So there are definitely tools out there, including zREPL, but there are also a lot of other scripts that rely on screen scraping the error output for proper error handling. And there, like a few classics are data set does not exist and all these kinds of errors. It's very important that these remain stable. So as an idea for making sure that we don't have any regressions in that regard, I would propose that we start recording the output of standard out and standard error of the entire ZFS test suite, or at least of the subset of the ZFS test suite where that makes sense, and put that somewhere, I don't know whether in the repository itself or in Git VFS or something, and have that be the baseline for any regressions with regards to error reporting. And I think like the pull request that introduces this feature should do that.
I feel like that's kind of a stretch. Like there are definitely aspects of the CLI that are stable and aspects that are really not. I mean, that's.
I think that figuring out what aspects are stable, like figuring out what we're changing about the output in a systematic way is a great idea. As to whether we would like not allow this to be pushed, if depending on what of the output is changed, I think is a super judgment call. And like, you know, probably some changes to the output would be fine and some changes to the output would not be fine.
Right. I think it has to be case by case, right?
Yeah.
Because like otherwise we're saying as part of this, there will never again be a visible change to the CLI, which I think is.
Yeah, I don't think
when you say it that way, I don't think it sounds that easy to even enforce that. So.
Yeah, we keep changing the output of zpool status all the time.
Yeah, that's a great example. So I think that I would definitely recommend implementing something like what Christian said to like record the output of all the commands when you run the test suite, and then do another run and be able to diff those so that we can know what was changed, and then apply that kind of case by case judgment call on whether those changes are okay, or like if it's easy to fix it up so that it looks the same, then you know we might as well do that.
Okay, definitely. It makes a lot of sense.
There's also another point I wanted to make that I experienced when developing zREPL, and that is that I found it very useful to have internal abstractions that are idempotent. And I think if we just move the ZFS commands into a library that works like the ZFS commands, we don't gain anything on that front. Now there's a question whether it is like, if I'm mistaken and only I find it worth having idempotent APIs, but in general, I find it very useful from a programmer's perspective to like not have to worry about I want to say I want this data set to be created and not handle the error, oh, it already exists. Mm-hmm. Well, fine.
Yeah, or if you have retries or something,
well,
the second one hits, and
I think that helps sometimes, but like what about the vast amount of things that you could have, so like let's say you create the data set and then that's fine, but then you go and like set a bunch of properties, make some changes to it, turn the compression on, do some writes, whatever, and then you come and do that original call that you want to be idempotent again. Are you like, what if that call, like when you created the data set, if you included like setting the compression to off or on or whatever, but in the meantime, that property has been changed, like, does that call also change the property back? And can you imagine under some conditions, at least, that like a strict mode where like you would want to know that the thing that you'd asked for hadn't happened or had happened or something had basically
Yeah,
if
definitely.
there's
would
kind of a
also want the
transaction, there's a
imperative.
transactional problem, I think, basically.
Yeah.
Right. That's the
I would not only have the idempotent APIs, but there's, so this was kind of the opener for a bigger thing. That is, what I do internally in zREPL is do almost everything with GeoIDs. So in particular, snapshot GeoIDs, like being and of snapshot GeoIDs, file system GeoIDs, these enable, for example, safe renames. ZFS rename cannot be implemented safely. Like you can never know whether between the decision that you want to make the rename and you actually issuing the ZFS call to make the rename, somebody swapped out the data sets underneath. And being able to express that operation with GeoIDs instead of the dataset paths, I would find that very helpful in a library. And the point I'm trying to make is, I don't think it's a good idea to have a kind of lateral movement from CLI to library, but instead there should be actual thought going into what is useful for programmability. Because sure, like in the 99% case, the paths work fine, but if you have concurrency in the game and all that, then I think it would be very useful to restructure a lot of the APIs, or at least have the thought in mind that at some point we want GeoIDs and not dataset paths.
you could
Yeah, that makes a lot of
imagine
sense.
you could imagine making the input to this library NV lists as well, so that like
Would very be in favor
you
of
could
that.
specify, you know, you could say like for the rename case, you could have the input be a source NV list, sorry, source data set and a destination, either one of those could be either a name. Well, I guess so. The source could be a name or a GID, and the destination would have to be a name. But you know, and then you could add, you know, like if you then wanted later on to add like an idempotent, like a create if not exists, or like those sorts of things, you could add those as extra properties that you don't have to necessarily support, and all we'd have to do in the function would be to reject properties that are not understood as being invalid, basically, and then you could have at least a backwards compatible interface.
Yeah, I think API design-wise, it makes very much sense to have all of these be NV lists. It's also great for like bindings for other languages, because essentially an NV list maps to keyword arguments. So I think that would be a really good way to design that.
Cool. I think there's a lot of good ideas here. And I think some of the stuff that you mentioned, Christian, is not necessarily like in the scope that was initially discussed, but so it would be, I think it'd be great if we could get some folks to work together on, you know, that. So if, you know, Christian, if you want to work with Mike on, you know, making sure that it would work for the use case that you're thinking of, then that would help to get it done. Why don't we don't have a lot of time left, and we have a few more interesting topics. So why don't we move on? And I guess as far as the next steps for this one, Mike, if I recall correctly, you have some cycles to work on this. So why don't could you put together, like, just kind of refine down further your proposal in terms of what the APIs will look like, and maybe come up with a couple more examples, and then we can like maybe send out an email to the mailing list, and then we can get some more discussion on, you know, the more concrete proposal for the error handling and all that.
Done deal. Sounds good.
Cool. Thanks a lot. So why don't I skip the, well, I'll mention the direct stuff, or I'll tee it up if Brian or I don't know if Mark is on the call, but Brian Atkinson or Brian Behlendorf, do you want to talk about the ODirect stuff? No, I'll keep talking until somebody unmutes themselves. So I was working with Brian and Mark maybe on the ODirect support, which we talked about at the last meeting. And folks raised some very good concerns there. So we took that away and had a bunch of discussions around the exact semantics that we wanted. I sent out an email with a summary, and there's also a design document that kind of weighs the pros and cons of a bunch of different decisions. I'm not going to go through and like outline every one of those. If I recall correctly, one of the main discussions at the last meeting was around what about concurrent stores that could happen. So like you're doing a write system call, that's ODirect, and the process has multiple threads, and one of the other threads could do a store to the buffer that you're using for the direct write. We want to make sure that the checksum, or like in a simple implementation, that might change the data like in between when we do the checksum and when we write it out to disk. So we decided that if you have checksums enabled or are using a bunch of other features, we're going to have to make a copy of that buffer in memory while we're doing the I/O. We couldn't really come up with any other reasonable semantics that fit with ZFS's ease of use and like not having a lot of sharp edges. Obviously, there's other ways that we could. The key thing is like the checksum has to be of the data that is actually written sent to disk, and making the copy is like how we would implement that. Twiddling with the VM subsystem is another way that we could do that, but right now we think that would be slower than making the copy, but that could change in the future.
It'd have to be a pretty big buffer for that to tap out, I think.
Yeah, well, I mean, some of the use cases are 16 meg buffers.
That might be big enough.
So, but on the other hand, I think a lot of the use cases here, at least for Brian and Mark, are using Lustre, which doesn't have to suffer this.
Which
copy,
is because it's in the kernel already.
Because Lustre is in the kernel already, yeah. So we can just say like, well, the kernel, like, if you use this particular interface, then you're guaranteeing that you won't change it, and that interface is not available. You know, that's not what we use for the write system call because we don't know that the userland isn't changing it. So that was the main kind of like change. We also like refined down the set of properties and kind of how we handled misaligned things from what we had discussed before. Hopefully that more or less makes sense. I'm not going to spend the time to like read out all of that unless there are questions, but I'm happy to.
I'm still a bit confused about where, like, the block alignment stuff makes sense because it's sort of disk IO-ish, but where exactly does the page alignment, the 4K alignment that is, stuff come from exactly as a constraint?
Yeah, so my understanding, and Brian or Brian, feel free to jump in at any point, but my understanding is that most of the other, it was kind of like everybody else does it, so we might as well too. And for reads, for writes, like if it doesn't align to the block size, then we're doing it as a buffered write anyways. So like we could, like there's really no reason that we couldn't handle things that are less than page size there as well, and kind of handle them equivalently. For reads, what we're doing for subblock reads is we're constructing an ABD from like the pages that were provided from the user, and then like some pages, other pages that we're just gonna like, that are scratch pages that we're gonna throw away. So I think that at least in the current implementation, those, you can only stitch together pages, not arbitrary sized things. So like if the user passed down like 1 kilobyte buffer, like they're like read it into this 1 kilobyte, then I think we would kind of have to read into our own buffer and then copy into their buffer, as opposed to like if they're passing down pages, then we can do this scatter ABD thing, which can be preserved further down. And I think on Linux, with the recent with the proposed changes, that scatterness goes all the way down to the disk drivers.
Yeah, and I would add, I mean, I've been looking around and there are different alignment requirements, kind of contingent on different file systems, but commonly page size is what they stick with. I mean, I've seen where they go down to like 512 bytes, but I've also found weird generic virtual file system hooks at it. Say if the file system block alignment is 4K, it allows you to do less than that, but they'll do like filling of the pages and things like that.
Yeah, I think that's definitely an area where we, like, if there's a good reason, we could definitely change that. That's not like a hard requirement on our side. We have a lot of wiggle room because all of the documentation is like, if it doesn't meet some alignment, then we won't do it and we'll give you an error. And a bunch of other file systems chose 4K or the page size. So we were like, all right, sounds good. But if there's like use cases where that doesn't make sense, like where they need to go down to 512 byte alignment or whatever, I mean, we can make that work too.
Yeah, we definitely do have some wiggle room as far as I can tell.
So the other thing that it was a little confusing, particularly in the preamble and talking about the motivations, it mentions a lot of, particularly the stuff about throughput and latency of write requests and stuff. It doesn't really feel like that's borne out in it. Like it feels like the classical O-direct justification is really just about managing your own buffers. So I don't know that it's right to set the tone necessarily on whether like huge write latency is acceptable or not. Like it may be, but I don't. It really feels like a side effect of the justification. Like it really feels like O-direct is for Oracle and MySQL and stuff. Like I'm going to manage my own giant buffer cache and I don't want the double caching. Feels like where O-direct really came from, rather than being about increasing throughput necessarily.
Yeah, I mean, I think there's two questions, right? One is kind of where it came from, and I think that's definitely true. And I think the other thing that's key about where it came from is that it also disables POSIX semantics of overlapping writes or overlapping operations, because POSIX says like if you're doing two operations, like a write and any other operation, and they overlap in the file range, then they happen in a defined order.
Right.
And most other file systems implemented that by saying, great, each file has a reader-writer lock. And so like while you're doing a write to the file, you cannot do anything else to the file. Right. And obviously that's horrible. So O-direct just throws that out, just says like, well, then we won't grab the lock. And overlapping reads and writes, like, who knows what'll happen?
It's your computer.
We know Oracle doesn't do that, so who cares? And we are not throwing that semantic out the window with O-direct, because like we've had range-based locking from day one. So you can have you have the overlapping things are ordered, but you can do two writes to different offsets concurrently. So I wasn't super concerned with where O-direct kind of came from originally, but I do. I think that you still have I hear your point. My thought was like, if it's really about buffer management, if it's really about like I just don't want this to be double cached, I'm telling you, I would prefer that you not cache this because you're just going to be wasting memory, and I want to use that memory for other stuff. Then a much simpler implementation is possible, which is like kind of what I did originally when I was prototyping this. So like, for example, for writes, like you don't need to bypass any of the code. You can just say like, do what we always did, but when the operation is done, throw it out of the cache. So like, there's no reason to do the write right away. We just do buffered style writes always, and then like at the end of spa sync, we notice, oh, like this is only in the cache because of it was a direct IO write, so we just evict it from the arc and the DMU and whatnot. I mean, I think that might work okay, but you do get like a huge performance win by not involving all of that, by having the opportunity to like streamline like the DMU arc, et cetera, like buffer management and all that stuff.
It does feel like there are a lot of copy on write sort of considerations too that are sort of different from classical extent-based file systems.
Yeah, and I think the primary consumer, like the folks who are actually doing the work to implement this, like Brian and Mark, you know, they care about this for Lustre and other kind of HPC workloads where it's not, I mean, yeah, the buffer management is nice because like they don't need to cache it, but I think that an equally large, if not larger consideration is that they want to maximize throughput and minimize the per byte overheads of like making copies, making multiple passes over the data and all that stuff. So I think they're concerned with that. On the other hand, like I and probably other like database type users are more concerned with the per block overheads of like, you know, instantiating a bunch of debuffs and a bunch of other stuff, which you know, you might have seen like from my work with send and receive recently is kind of all about minimizing those kind of overheads. And I think that's, if you take the principle of like, we really care about maximizing throughput, then I think that those implementation details kind of flow more naturally from that than if we're just saying that it's about you know, not using up a bunch of memory.
All right, so I think given all of that, and the fact that it does feel like this is going to be conceivably breaking for people that are currently using ODirect without, because the implementation today basically just doesn't do anything, right? I mean, that's
yeah. So the one thing that would break is if they're not, like right now there's no alignment
right.
constraint. So I think that is the one and hopefully only thing that would break. That would be like, you actually get a different result as opposed to performance being different.
Right. And so from that, I think, I do think we should consider having it be the current behavior today should still be the default behavior, and that you should turn this new behavior on, which, you know, easily the people doing Lustre and stuff can easily like opt into this because they're already opting into presumably a bunch of other stuff as well. But then out of the box, like merely by rebooting onto this update, your application that makes unaligned writes is not going to break, basically.
Yeah, unaligned ODirect writes. Yeah,
I think that
that's a good point.
Because also I think the other platforms like FreeBSD and Illumos, I think, allow quite a lot more unaligned writing behavior. I think by default, for instance. I believe that's true, but we can confirm that. But I think that's true.
Yeah, I think that's a fair point. Another way that we could, I think your point is that like we're making things fail which didn't otherwise fail in the default case.
That's right.
Another way to address that could be to make it so that like unaligned acts, like no unaligned ODirect, like there's no alignment requirement for ODirect, and we will just, you know, do it. Like if you do a 1 byte unaligned read, then like, all right, sure, like we'll just read the whole thing, copy that byte out for you. There you go.
We'll fix it in post-production. But like, I think, yeah, that could be another thing where like by default, you could imagine then the default mode and then a strict mode if you want the alignment for some reason.
That's kind of, we could do that.
And the other then, yeah. Oh, the other thing that does feel like a breaking change is pools with no redundancy and no encryption and no compression. I guess you have to turn the checksums off, right, to get the where the buffers can be twiddled during the write.
Yeah.
Okay, so that's not going to be by default.
And I mean,
Okay.
if you turn off all those things, then I mean, it doesn't. Once you turn all that off, then ZFS doesn't care, and so I think it's fine. Like ZFS is going to copy through your buffer, and the disk is going to copy through your buffer, so semantics are the same.
What I haven't looked at the change yet, but from a structural perspective, it seems like the list of conditions under which the unlocked buffer read can happen is obviously pretty long and complicated.
Yeah.
And, what I remember from some of the encryption work that went on for a really long time, some of the last things that we chased down were like not the encryption, decryption stuff, not necessarily always happening at all the places that it needed to happen in the pipelines. Because the abstractions didn't, like there wasn't necessarily one clearinghouse for where those specific decisions needed to be made around some of the new flags. Is the implementation of this where we're making that decision whether the buffer unlocked read can happen or not? Is that in a pretty singular place, like
So
from a complexity perspective? Like,
yeah, I would think so, because I think the issues that you're talking about are with, like, when you're dealing with an encrypted data set, sometimes you don't need to decrypt it, and sometimes you do. And that's where the trickiness came in.
right.
Versus in this case, like, if encryption is enabled on the data set, then you do not get this super duper fast path behavior. And the encryption can't be, like, that's set at creation time and does not change. So I think that's fine.
But the fast path decision, though, is sort of being made in one place, though. Is that true? Or
yeah, that should be
okay.
made in one place. We're almost out of time. I just wanted to mention one other thing about the alignment that relates to what you're saying, which is one of the reasons that we thought that maybe we should be failing the direct operations that have poor alignment is that applications might be doing direct operations and then, like, checking to see if they worked or not, and if they didn't work, then, like, increasing the size that they're doing, or, like, otherwise modifying their behavior to be more optimal. So, like, telling them, like, hey, you tried to do this. I can't really do it fast the way that you're asking me to. So try again. Like, try something else.
I'm definitely in favor of the strict failure when you are trying to go fast, and the only way to go fast is a particular constraint must be met. It definitely makes sense to have, like, an E in our case or whatever for that failure.
Yeah,
I just
and in
don't
that
know
case,
that
maybe
it should be the default. That's the
yeah. And in that case, maybe the strict would require block size alignment, not page alignment.
Because that would be where the IO decision is truly faster or slower, right? Like if you've got a whole record right or not or whatever.
Yeah.
Yeah,
so
in the initial pull request I have up, I have a lot of those data set properties, but we're definitely trying to distill them down.
Yeah, we're trying to distill them down. It may be reasonable to like we still just have the one property, but to have a disabled, default, strict, and always, right? There's just one more value to that existing property.
Right, and there's still kind of like levels, like the shells of an onion, basically, in terms of behavior.
Yeah.
I apologize, folks. We're out of time. There were a few things that we wanted to get updates on, and then also calls out for code reviews. I'm just going to say what those were, and then we'll discuss them next time. And please add. I'll add this on the Slack channel as well. So the status updates. Josh Petzel already posted a status update on the Panzura dedupe. It's they haven't made much progress, but they still want to. Alan has the status update on dedup log and the DDT limit, and I saw that he just opened, perhaps during this meeting, a pull request on the dedup limit or dedup ceiling. There are also pull requests out that need reviews on persistent L2 arc, Z standard compression, and the dedup load, which is like a prefetch, or like, please go read in the dedup table from disk synchronously. So people who are in a position to review that code, please do so. That stuff is ready to go. And we will see you again in 4 weeks at the later time. So that should be April 28th, 1 p.m. Pacific. Thank you all.
Thank you.
Thank you.
Bye-bye.
Thanks.